Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 4 Vectors and 3-dimensional Geometry. Topic Vectors and 3-dimensional Geometry. Exercise Miscellaneous Examples on Chapter 10. Ahanba wahang, write down a unit vector in xy plane making an angle of 30 degrees with the positive direction of x-axis. Positive direction of x-axis ta 30 degrees semba xy plane da leiba unit vector ama putu'u. Let OP be the unit vector making an angle of 30 degrees with OX positive direction of x-axis. Also, projection of OP on x-axis is OP cos of 30 degree. OP is unit vector whose magnitude is 1. Cos 30 is root 3 by 2, which gives root 3 by 2. Also, projection of OP on y-axis is OP sin theta. OP sin of 30 degree, which is half. Therefore, OP, the required unit vector is root 3 by 2 times of ik plus half times of jk. For question number 2, find the scalar components and magnitudes of the vector joining the points P and Q. Apiba point anisi samjinaba vector adugi scalar components amasung magnitude sing putu'u. We have OP piramiba point P ki coordinates sing aduda ijk na purirabadi mathang sitna P hariba point adugi position vector khange asumna Q ki position vector di OQ na khangnarani, which is equal to this. As in this picture, P dagi Q satpa vector haibasi P dagi Q OQ minus OP na P gani. OQ is OQ dagi OP khaidokrabadi x2 minus x1 times of ik plus y2 minus y1 times of jk plus z2 minus z1 times of kk. Therefore, scalar components of PQ vector are I ki coefficient x2 minus x1, yj ki coefficient y2 minus y1, k ki coefficient z2 minus z1. Also, magnitude of PQ is square root of this square plus this square plus this square. Question number 3. A girl walks 4 km towards west. Then she walks 3 km in a direction 30 degrees east of north and stops. Determine the girl's displacement from her initial point of departure. Let OQ represents the displacement of the girl who walks 4 km towards west. OQ ashin nupi macha aduna west from the 4 km satpagi displacement to Mount Silasi. Let QP vector represent the displacement of the girl 3 km east of north making 30 degree. Northagi is from a 30 degree semaga satpa making 3 km to OP vector sina Mount Silasi. Then OQ becomes minus 4i and OQP equal to QP sine of 30 degree, QP sine of 30 degree minus I plus QP cos of 30 degree J. QP is 3 and sine 30 is half. QP is 3 and cos 30 is root 3 by 2. Evaluate torabadi we get this masina QP vector adu phangi. Therefore, OP ahobadagi mahak ki girl's displacement from her initial point of departure digi OP vector si or puthokadabadu, which is sum of OQ vector plus QP vector. OQ vector ki value minus 4 I ke pisalani QP ki supisalani manaba I yawa tamani si punjalabadi we get this J yawa tamani si punjalad si phange. Asumna aikoina girl's ki displacement from her initial point of departure to puthok. For question number 4, if a vector equal to b plus c, then is it true that magnitude of a equal to magnitude of b plus magnitude of c? Justify your answer. Let b vector denotes ab, c vector denotes bc, so that a vector is ac as in this picture. Then a vector equal to b plus c na pirani. but magnitude of A is equal to AC, magnitude of B is what? AB, magnitude of C is BC. The sum of two sides of a triangle is greater than the third side. Triangle amagi side anigi asang basing tinchinaba folsina ahum suba side tegi chawba hele. Then AC is less than sum of AB plus BC. AB AC is what? Magnitude of vector A. AB is what? Magnitude of vector B. BC is what? Magnitude of vector C. Thus, the statement is not always true. Managadra hangbasidi matam punamakta chumdre. Question number 5. Find the value of x for which this is a unit vector. Apiba vector C unit vector oinaba x ki value putu haibani. Apiba vector C unit vector oirabadi mahaki magnitude 1 ga manarani. Mahaki magnitude square root of x square plus x square plus x square equal to 1, which gives square root of thrice x square is 1. Squaring on both sides we get x times root 3 equal to 1. Squaring we get x equal to plus minus not which gives x equal to plus minus 1 by root 3. Question number 6. Find a vector of magnitude 5 units parallel to the resultant of the vectors A and B. A amasu B ge resultant the parallel oiba magnitude 5 oiba vector ama putu u haiba. Let C equal to A plus B. Then C as the vector and C tinsinaradi thrice I k plus Z. Required vector is 5 times of unit vector along C vector. C vector is this, whose magnitude is also this. Simplifying, we get this, which is the required unit vector. Required vector of magnitude 5 units along the resultant of the A vector and B vector. If A vector equal to this, B vector equal to this, and C vector equal to this, find a unit vector parallel to the vector twice A vector minus B vector plus twice C vector. We have twice A vector minus B vector plus twice C vector equal to twice of A vector singular, B vector singular, C vector singular. Sum up the we get twice I cap minus twice J cap plus twice K, whose magnitude is this root over 3 square plus 3 square plus 2 square, that is square root of 22. Therefore, required unit vector along the above vector is the vector itself divided by its magnitude. We get 22. Square root of 1 by square root of 22. Question number 8. Show that the points A, B, C are collinear and find the ratio in which B divides AC. A, B, C hariba point ahum asi line amada lay utlu aduga find the ratio in which B divides AC. B na AC bo karamba ratio da khaidokpage madusu putu. Here A is this, B is equal to this, C is equal to this. We have AB vector puthokani asumna BC vector puthoklani. Vector AC vector su puthoklasi sumna phange. Now magnitude of AB vector is 2 times root over 14. Magnitude of BC is also 3 times square root of 14. A magnitude of AC is also 5 times square root of 14. Thus, AB plus BC equal to AC. Lai makak ahum sige apikpa ani si tinjinaraga chawba si phangabade ABC are collinear point ahum si collinear ore. Find the ratio in which B divides AC. B na AC bo karamba ratio da khaidokpage madusu puto. Question number 8 continued. Let A, B, C be the position vectors of A, B, C. Points sing adugi position vectors into respective letters sing sina denote torasi. Then A equal to this, B equal to this, C equal to this. Let B divide A and C in mu to 1. B na A ga C ga samjinaba lai adubo mu to 1 da khaidi we hane laurasi. Then B vector is equal to mu C times mu times of C vector plus 1 times of A vector by mu plus 1. C की value पिछला, A की value पिछला, B की value पिछला C. नकन अनिमक्ता की I की coefficient compare करो, J की coefficient compare करो, K की coefficient compare करो, we get this. मसीदगी I कोई ना mu की value dot 2 by 3 फंगे. Therefore mu is to 1 है बदी 2 by 3 is to 1. That is 3 ना पूरी ना बदी we get 2 is to 3. Require ratio dot 2 is to 3. Question number 9. Find the position vector of a point R which divides the line joining 2 points P and Q whose position vectors are this and this externally in the ratio 1:2. P ga Q ga samjinaba laibu 1:2 da khaidokpa mapana khaidokpa point adugi position vector putu. Also show that P is the midpoint of the line segment PRQ. The position vector of the point R is section formula for external division palabadi 1 siga a minus thrice b siga purinani minus 2 ga twice a plus b ga purinani divided by 1 minus 2. Simplified orabadi thrice a vector plus pi b vector. Also the position vector of the midpoint of RQ ki midpoint ki position vector the R ki position vector plus Q ki position vector by 1 plus 1. Simplified orabadi twice a plus b, which is the position vector of the point P. Shinakarita A. Thus P is the midpoint of RQ. P se RQ ki midpoint ori. For question number 10, the two adjacent sides of a parallelogram are this and this. Find the unit vector parallel to its diagonal. Also find its area. Vector anisina adjacent side oiba parallelogram adugi diagonal adugi maikaida satpa unit vector putu u haibani. Also area so let A denotes the first vector and B denotes the second vector. The diagonal is given by A plus B, which is this. Therefore its magnitude is square root of 3 square plus minus 6 square plus 2 square. We get 7. Therefore unit vector along the diagonal A vector plus B vector by its magnitude, which is equal to 1 by 7 times of this vector. Again A cross B is this. Determinant from the itoni first order expand to oni. We get 22 ik plus 11 times of jk. Therefore area of the parallelogram the magnitude of A cross B A cross B ki magnitude for lastly 11 times of square root of 5 square units pange. Question number 11. Show that the direction cosines of a vector equally inclined to the axis or x or y or z are this. O x or y or z equally inclined to a vector adugi direction cosine singadu 1 by root 3 1 by root 3 1 by root 3 organi proof to. Let a vector equal to xi plus xj plus sk be the vector which makes equal angle with the axis. Then its magnitude is this x times of root over 3. Therefore direction cosines of a vector RL equal to x by x divided by x root over 3, that is 1 by root over 3. Similarly m is also 1 by root over 3, n is also 1 by root over 3, hence on. For question number 12, let A equal to this, B equal to this and C equal to this. Find a vector D which is perpendicular to both A and B and C dot D is 15. A, B, C vector ahum I, J, K da phongdokpa vector ahum piramle. D have a vector ama putu A, B dana perpendicular oiba C dot D adona 15 oiba. Let D equal to x I k plus y j k plus z k k be the required vector. Then A ga D ga perpendicular oyana piram labanina A dot D to 0 orani. That gives this into this equal to x plus 4y plus 2z equal to 0 equation 1. B ga D ga su 0 perpendicular oibanina dot 0 le dot pangthok labadi equation 2 asi phange. C ga D ga purina bada dot pangthok for 15 ni maduna aikoina x y z jawa equation amaga phange ahum equation ahum phange 3 unknowns ki. Equation ahum se haudik solve tausi. By cross multiplication of equation 1 and 2, 1 ga 2 ga cross multiplication taurabadi x divided by 20 plus 4 equal to y gi mamangda leba minus formula gi minus ni 7 minus 6 equal to z by minus 2 minus 12. Simplest form the thame makoi kudimak lambda ga mana hale. That gives x in terms of lambda that is c ga manare. Therefore equation 3 gives equation 3 the x y z ki value sing to pisila lambda ka tang yaw equation ama phange madudagi lambda ki value si 5 by 3 phange. Therefore x becomes this, y becomes this, z becomes this. Haibadi x y z to in terms of lambda da phongdo bani lambda ki value 5 by 3 pisila badi x y z ki value phange. Therefore require vector d ni which is x times of I plus y times of j cap plus z times of k cap. X y z ki value pisalaga si phange masina puthokadaba vector don. For question number 13, The scalar product of the vectors I plus j plus k with a unit vector along the sum of the vector this and this is equal to 1. Vector and sigi sum gi paring the sapa unit vector duga ahan ba vector suga gi scalar triple product to 1 ga manarabadi. Find the value of lambda. Let A denotes the first vector, B vector denotes the second vector, C vector denotes the third vector. Then B plus C is equal to this. And the unit vector along B plus C is B plus C divided by its magnitude. We get this. By question, a dot of this latest vector, this vector is given as 1. Scalar product pang to all C value pisilo the dot product I coefficient purinarani. Plus jj coefficient purini plus k coefficient purinaraga 1 ga manare cross multiply tawradi si pangani. Squaring both sides we get this masidagi lambda ge value ado 1 phange. To kadaba lambda ge value do 1. Question number 14. If a vector, B vector, C vector are mutually perpendicular vectors of equal magnitudes, so that the vector A plus B plus C is equally inclined to A vector, B vector and C vector. Here magnitude of A equal to magnitude of B equal to magnitude of C equal to lambda C. Also A dot B equal to B dot C equal to C dot A is being equal to 0 makoi khudingmak amaga amaga perpendicular oi haibanina. Let alpha, beta, gamma be the angles made by the vector A plus B plus C with A vector, B vector, C vector respectively. Then cos alpha the angle between A vector and sum of these three vectors, which is using scalar product of two vectors. We get this. A no dot pang over you get this. You see the magnitude of A square lady. Both sides take magnitude of A acid, magnitude of A square lady. A kakra we get this magnitude of A the lambda. Similarly, cos beta so magnitude of B by magnitude of A plus B plus C, lambda by magnitude of A plus B plus C. Assume cos gamma so lambda by magnitude of A vector plus B vector plus C vector. Right? Ahum si manarabadi. Thus cos alpha equal to cos beta equal to cos gamma. Shinakarita A plus B plus C is equally inclined with A vector, B vector and C vector. Equally inclined that we have it ulle. Question number 15. Prove that A plus B dot A plus B is equal to magnitude of A square plus magnitude of B square if and only if A, B are perpendicular given A vector does not equal to 0, B vector does not equal to 0. Suppose A and B are perpendicular vector and is perpendicular or haina lowrasi perpendicular or abadi dot 0 oirani. Now sigi scalar product vector mari sigi sum laire vector mari sigi sum A ga B ga perpendicular mina middle term and is 0 chakrani magnitude of A square plus magnitude of B square. See now result ado prove tore. Again suppose A plus B dot A plus B is equal to magnitude of A square plus magnitude of B square. Expand left see expand to see phange ahan version C manare ani subna C manare. See the scalar product of two vectors is commutative, therefore it can be written as 2 times of A dot B. Cancelling equating both sides we get A dot B is 0. This gives A is perpendicular to B. Hence Sitsumadi have to quite utle. Question number 16. Choose the correct answer in exercise 16 to 19. If theta is the angle between two vectors A and B and their scalar product is greater than or equal to 0 only when theta is lying between 0 to pi by 2, theta is lying between 0 to pi by 2, including the two ends, theta is lying between 0 to pi, excluding the 2, theta is lying between 0 to pi, including 0, excluding pi. Karamba chumbage hangbani. A dot B is greater than 0, hierarchy A dot B equivalent value pira A vector B vector single C always makoi ki magnitude T greater than equal to 0 ni, greater than equal to 0 ni. That gives cos theta is greater than equal to 0. Cos theta na 0 dagi 0 amas 0 dagi chawbare theta do 0 degree oibama 90 oibama ani sigi marak to leibe any number amo oigani. Correct answer is B asina chume. 17. Let A vector and B vector be two unit vectors and the theta is angle between them. Then A plus B is a unit vector if A plus B is unit vector oigani. magnitude of a plus b is 1. It shows that magnitude of a vector plus b vector whole square is equal to 1 square, which is equal to this into this. Mark expansion we get this. Sidagi aikon a c unit vector ni b c unit vector ni 1 1 pisilo. Sidagi a dot b is minus half. A dot b the magnitude of a into magnitude of b cos theta equal to, which is equal to cos of 120, that is twice pi by 3. Magnitude of a so 1 magnitude of b so 1 cos theta की value na minus 120 pirabadi theta can take twice pi by 3. Option correct, option D ore. Question number 18. The value of this scalar sum of these three scalar trivial product is karamba chumbagi pangthoksi I dot j dot k di I ni I dot k di minus j ni I dot I cross j di k ni hariba I dot I di 1 phangani minus 1 phangani 1 phangani kakthana di 1 tare. Correct option is C ore. For question number 19, if theta is the angle between any two vectors A and B, then magnitude of A dot B is equal to magnitude of A cross B when theta is equal to. Correct answer D B or A. Question number 6 of 10.4. Thank you for watching video.